All right, so our last lesson on limits, and we've been looking at the limit as x goes to a number. So here as x goes to 0, we can say that the y value goes to infinity. So in this lesson, instead of going to a number, x is going to go to infinity or negative infinity, and then we follow the graph out to the right or to the left. So if we go out to the right, the y value is approaching 0. So we want to pay attention to where this is telling us to look on the graph. This will come up in one of the examples. Let's review that. If we use square root of x squared, it's absolute value of x. But that's only if it's square root and we have an even. And what's happening is x could be negative in here. You could put in a negative, but when you square it, it's positive. And then when you square root, it goes back to, we might say square root of the square cancels, and we'd say that's the answer, but this is not it, because when I look at x, I could say that could be any positive or negative number, which it was when I put it in there, but when you do all these things to it, it has to be a positive. So we say that it would be absolute value of x. The answer to this is always positive, and that's what that's saying. So we don't say it, we don't write that. Okay, another connection to make is in pre-calculus we looked at the horizontal asymptote, and we get this by comparing the exponents of, or the degree of, the numerator and denominator. If the degrees are equal, then we can take their coefficients, and that's the horizontal asymptote. We also saw in pre-calculus that if we have a higher degree in the denominator, the horizontal asymptote is y equals 0. And when we look at it with limits, if we consider what happens as x goes to infinity, we'd say the numerator goes to infinity and the denominator goes to infinity. This is indeterminate. And what we're going to do today is rewrite the numerator and denominator by multiplying by 1 over the highest degree of the denominator. So this will create terms that go to 0. Put an x under every term, 2x over x, 1 over x, 3x over x, and minus 1 over x. So this goes to 0 because it's 1 over infinity. 1 over infinity, these are zeros. The x cancels and we get 2 over 3. The same thing that we have from that shortcut from pre-calculus. So let's try this analytically. If x goes to infinity, we'll have 3 minus infinity, and this will be infinity. That's indeterminate. So we have to divide all the terms by the highest degree, the highest exponent of the denominator. So we can multiply by 1 over x cubed All right, so we do have some reduction here, and now we see a constant divided by infinity, that's 0. Constant over infinity, that's 0. So we have 0, and then the denominator is 3 minus 0, so we know the limit is 0. If we look at that graphically, we have an asymptote around here, just before 1, and x-intercept right after 1. So the graph goes down and then comes back up towards the x-axis. So there's the limit at infinity. It's going out to the right. The other part of the graph doesn't matter in this problem, but it goes like that and something like that. And numerically, if we look at a table, we need to make sure we use numbers that are going to the right, getting large to the right. So that's 0.5. Negative 0.0057, negative 7 times 10 to the negative 5th. So make sure you know that this is a very small negative number and it's getting closer to 0. So we can see the limit. The y value is getting closer to 0, and all the representations agree. Pause the video and try this one. Make sure you do it graphically, numerically, and analytically. So if we substitute infinity, we'll get negative infinity over infinity. That's indeterminate. And let's rewrite. Look at the highest exponent term of the denominator. So that's 1 over x. We want to divide everything by x or multiply by 1 over x. So just put an x under each term. and we have 3 over x minus 2 over x. Nope. The x's cancel, we just get a 2. The x's cancel, we get a 3. And that'll stay the way it is. As x goes to infinity, this is 0, that's 0, so it's 0 minus 2, 3 minus 0, and the limit is negative 2/3. Here we're going to the right, so let's choose numbers getting large to the right. And we have 0.5, negative 0.5862, and negative 0.6589. If we keep going, that's going to approach negative 0.6 repeating, which is negative 2/3. So this is approaching negative 0.6. And if you didn't see that in this table, then just go further, choose 1,000 and 10,000, and you'll just see more 6's appearing here. All right, we have a vertical asymptote at positive 1/3, and the x-intercept is at 3 over 2, 1.5. Here we see that the horizontal asymptote is at negative 2/3. But this is the only part that we're concerned with in this problem, because we're looking at x going to the right, and we know that the y value is approaching negative 2/3. Alright, try this one, and if you get stuck with the algebraic strategy, just look at the graph, and I think it'll make sense. Pause the video and try that one. If we put infinity here, we have negative infinity. In the denominator, we have positive infinity. That's indeterminate. So let's divide every term by the highest degree term of the denominator, and that'll be 1 over x. Here we have 2x and 3 minus 1 over x. And now we have 0 minus infinity. We have 3 minus 0. So it's just negative infinity. As x goes to the right, let's just go further out here. Negative 6.793. At 100, it's negative 66.88. And then at 1,000, negative 666.9. We know that these numbers, the y values, are going to negative infinity. And so this has a vertical asymptote around here, and it has a slant asymptote going through this point out to about here. And the intercepts aren't accurate. This one's a little off. But all we're looking at is the behavior to the right. So what is this doing? What is the y value doing? As we go to the right, the y value is going to negative infinity. So this has a little different strategy. If we substitute negative infinity, we're going to square the negatives. That'll be positive, but this is going to go to infinity and negative infinity. So that's indeterminate. We need to cancel. We need to get a x under everything, but now we have this radical. So we want, this has an overall degree of 1 because we're square rooting a square. So if we just divide everything by square root of x squared, let's divide by the square root of x squared. We can write this, so we're going to have x divided by that. And the radical, we can divide inside the radical, and we have x squared over x squared. And that's why we wanted it to have the radical, so we could multiply the radicands. But then remember that this is actually the absolute value of x. And now let's think of the signs. This would reduce to either 1 or negative 1. Well, we have x being negative, so this is negative. That's positive. We know the numerator is negative 1. This will be 0, and that is 1. So we can see the limit is negative 1. So that's negative 1 and positive 1. And to the right, it's going to positive 1. And to the left, it's going to negative 1. And we see that with the table. we want to have numbers that are going left and we know that on the values are not -1 because there's an asymptote, but on the calculator that's what it's giving us just because it's so close. We can see as we go to the left the y value approaches -1. Alright, and pause the video, try that one. If we put negative numbers here, we get a positive, so the numerator goes to positive infinity. In the denominator, we'll have a positive here minus a smaller number, so this is always positive, and we have infinity over infinity. That's indeterminate, so we have to rewrite it. And we have an overall degree of 1 here, so let's divide everything by square root of x squared. So this will be absolute value of x. And let's put that x squared inside. So we have x squared divided by x squared. Let's just rewrite the denominator. So the x's will be negative. We have a negative x times a -3, that's positive, over a positive. So that will be a positive 3. And here we have 1 over infinity is 0. 0, and we have 1 minus 0. So we see the limit is 3. And here we have I'm not sure of the x-intercept, but there's a vertical asymptote at -1, and that's when the denominator is 0, and here is the other part of the graph. We can see as x goes to the left, the y value is approaching 3. If this were a positive infinity, y value would be approaching -3. And if we show it numerically, we are looking to the left. We might have these numbers. So it's undefined at -1. At -10, we have 3.268, and at negative 100, 3.0252. So we can see these y values approaching 3. And so we confirm that the limit as x goes to negative infinity is 3. And we'll stop there.